All right, today's lesson is on probability and the addition rule. Go ahead and go to the homework page and print this out because this is homework/notes. All of these problems must be done to earn full credit. All right, I bet a lot of you already know some probability. If I said, what is the probability of getting a 1 on a dice or a die, you'd say 1 out of 6. So probability can be a fraction. It's never bigger than 100%. Highest it can be is 100% or just 1. 100% is 1. 50% is 0.5 or a half. Those are all acceptable, right? But a probability is always over the total or the number of outcomes in a sample space. The probability of something happening is the number of outcomes in the event over the number of outcomes in the sample space. The sample space is all the probable outcomes. Like this one, a 12-sided die. You know why they call it 12-sided die? Because it has 12 sides. And they're numbered 1 through 12. So the total outcomes would be 12 on any probability on one of these. All these answers are over 12. Right, so we have two events. We have event A is rolling an odd number, and B is rolling a number greater than 7. So the first thing I'm going to do is always start in the middle. How many numbers are greater than 7 and odd? Well, 9 and 11. Because 8, 10, 12, they're greater, but they're not odd numbers. In this circle must be odd numbers. So 1, 3, 5, 7. And you see in this circle, 1, 3, 5, 7, 9, 11. Those are all odd numbers. In B, numbers greater than 7. Well, 8's greater than 7, 9, but it's already in there. 10's greater than 7, 11, and 12. Now, does this include all the numbers between 1 and 12? 1, oh, I don't see 2. 3, I don't see 4. 5, I don't see 6. 7, 8, 9, 10, 11, 12. So that's all of them. So 3 numbers that are not in this box, the samples, or in either one of these circles. So over here, this represents probability. So the probability of A, which just means what's the probability of rolling an odd number? Well, 1, 2, 3, 4, 5, 6 out of the total number of outcomes, which is 12. So this is 1/2 or 0.5 or 50%. Now we always want to reduce our fractions, so any one of these is correct. Again, it can never be larger than 1. And remember, this means not. So what's the probability of not getting a B, or the complement of B? So if you look at it this way, those are all B. How many aren't in B? 1, 2, 3, 4, but don't forget these. 5, 6, 7. So it'd be 7 out of 12. Now if you wanted it as a decimal, you could take your calculator and divide. It's 0.58. It's approximate because that's not exact. 0.58 or 58%. And all those are fine. This means intersection. I'll go over what it means in this problem, but the intersection would be just these two. So there's 2 out of 12 or 1 out of 6. You have a 1 in 6 chance of getting one of these numbers. Now, what is 1 over 6? 0.16 or 0.17 if I round to 0.17 or 17%. Again, any one of those makes sense, except for this one round or reduce. So what does this actually mean? Probability of getting a 9 or 11. So that would be an odd number that's greater than 7. How many odd numbers are greater than 7? Just 2 of them. Okay, this is the union of A and B. All right, there you can add all these up, or not add them, but just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12, or these are not in the union, just take away 3 from 12 would be 9 out of 12. Reduce would be 3/4. I don't need a calculator for that. It's 0.75 or 75%. So again, either one of these is an acceptable answer. They all mean the same. So what did this mean? What's the probability of getting an odd number or a number greater than 7? Okay, this one is the probability of an odd number intersect not an odd number. Okay, so odd number. So let me use the pencil again. So an odd number and intersect not greater than 7. So what's not greater than 7? This one, this one, oops, this one, that's not greater than 7. These also. All right, so how many of them are there? Well, I'm only looking at the overlap, because the intersection is where they overlap, and there's only 1, 2, 3, 4. So it'd be 4 out of 12, which is 1 over 3, which is 0.33. Of course, that goes on forever. Or 33. I'm going to put in a third percent. Right? Let me erase those. See, I might need to do this again just so I understand what they're asking for. Intersection is what they have in common. A union is just all of them combined into one. So let's take a look at this next one. It says not A. Okay, that's not right here. Sorry, not A. So I'm going to just circle the ones that are not in A. All of these are not in A. Again, this is intersection. Intersection is what they have in common, so not in B. This is not in B. These 4 right here are not in B. These 3 are not in B. So how many of them are common? Well, the ones that have 2 circles on them. So that again would be, not again, it's the first time, 3 out of 12 or 1/4, which we all know is 0.25 or 25%. Using this little circle, circling these things, if it's an intersection, it would be circled twice. If it's a union, it would be anything that's circled. All right, of course, you're going to do this one on your own down here, and you must do this one too. And on the back, this is what we call the addition rule. And there's a very simple formula for that. And it's this one right here. Right? The probability of, this really stands for probability of A or B. The event A happening or B happening would be the probability of A plus the probability of B minus the probability of A and B, or their overlap. Because if I already include it here and here, I can't include it twice. So I take away that common one. The easiest way to do these is draw yourself a picture. And I'm going to put these circles in here. My first circle is going to be the kids who take honors. My second circle is going to be the students involved in a club. Now, if students belong to both of them, there's an overlap, so that's why I drew the circles like that. So this is a club. Now, if you remember on the assignment from the day before, we start in the middle. Well, this middle means they're in an honors class and a club, so I look for that. It's right here. 35% are involved in both. So this is 0.35. And I know this H circle for honors has to be a total of 70, where I already have 35, so 35 would go in here, because both of those are in the circle H, and 35 is 70, right? Involved in a club is 50%, we already have 35%, So this would be 15%. Now, after you get that done, I want you to go ahead and add all these up. 0.35 plus 0.35 plus 0.15, and you notice that's only 0.85. Well, this sample space has to add up to 100%. So there's 15% aren't in an honors class and aren't involved in a club. Now, what is the probability that a randomly selected student is an honors class or in a school club? So that'd be honors or school club. And that, according to the addition rule, is the probability of being on honors plus the probability of being in a club minus the probability of being in honors and club. All right, so I have to subtract. See, if I did probability of honors, that's this whole circle. If I did club, that's this whole circle, and I'm using that number twice. I can't do that. So probability of being in honors, I know is 70%. Probability of being in a club is 50%. But the probability of being in both was 35%, because this cannot be larger than 100, and 70 and 50 is 120, and it can't be that high. So what's the probability they're in one or the other? Well, I add these up. 0.7 plus 0.5 minus 0.35, and I get 85%. Or 0.85, where I could use 85%. All right, now you have to finish the rest of these, but again, a suggestion, draw this little picture. It makes them so much easier. Don't forget this formula. And have fun. This is a lot of fun. Shout out to the Gelato Club again. Have a wonderful day. Bye.